Okay, we're continuing 1.5 and doing algebraic properties of limits. These are properties of limits that work only if the individual limit exists. So the limit as x approaches a of a constant is the constant. Limit as x approaches a of x is just plugging in a. The things we care about is if I times a constant, I can do the limit and then multiply the answer by the constant. If I'm adding two functions, I can apply the limit individually and add them. If I'm multiplying, I can apply the limit and then multiply the results. Say if I'm dividing, you can divide the results. If I'm doing an exponent, you can do the result to an exponent. And if you're doing a composition, you can apply the limit to the inner function and then apply the limit to the outer function. Okay, so let's try example 2. Okay, I'm going to show the first step, which is going to be an unnecessary step in a second, but I'll show you what we're doing. Okay, so I'm going to break this up. I'm going to say I want to do the limit as x approaches 1 of 5, and then I'm going to do 3 times the limit as x approaches 1 of f of x. I'm just applying the limit to the function. Now, if I did the limit as x approaches 1 of 5, it's just 5 because it's constant, plus 3 times, what is the limit as x approaches 1 of f of x? It's given to us, it's 4. So this is 5 plus 3 times 4, which is 17. Okay, and you do not need to show the first step. You can skip straight to here. So on the next one, I might try to skip, I think. Okay, so the next one says the limit as x approaches 1 of negative g of x plus f of x squared. Okay, so I'm going to leave the negative alone. Let me apply the limit as x approaches 1 of g of x. What is the limit as x approaches 1 of g of x? That is this one, 6. So negative 6 plus, now I'm going to apply the limit as x approaches 1 to the f of x, and then I'm going to square the result. So limit as x approaches 1 is 4, and then I'm going to square the result. So this is negative 6 plus 16, which is 10. Okay, one more. This one's a little weird though. Okay, it says the limit as x approaches 1 of f to the negative x. So the problem is they have actually changed the sign of the x. So we're going to reinterpret this. Instead of saying the limit as x approaches 1 of f of negative x, I'm going to say that that is the limit as x approaches negative 1 of f of x. Okay, and then look at that. If x approaches 1 and I plug in a negative x, that's the same as plugging in negative 1. So I'm going to rewrite this as x approaches negative 1 of f of x, and that's still plugging in negative 1. Okay, and then let's go to the next one. And then if I apply the limit as x approaches 1 to g of x, I get 6. And then I divide it by 2. Now the limit as x approaches negative 1 of f of x is 2. So I'm going to get 2 plus 3, which is 5. Okay, example 3, the table below gives selected values of the function f, g, and h, and these are limits, and these are function values. It says, what is the limit as x approaches 5 of h of x times f of x plus 2g of x minus h of 5? Okay, so the limit as x approaches 5 is applying to here to here. Okay, so I'm going to try to apply the limit as x approaches 5 to each of these individual functions, and then I can deal with the results. So the limit as x approaches 5 of h of x is 5. And then in parentheses, the limit as x approaches 5 of f of x is 6. Plus 2, the limit as x approaches 5 of g of x is negative 1. And then at the very end, it says minus h of 5. What is h of 5? H of 5 is 3. Okay, and then I'm just going to go ahead and evaluate this. This is 5 times 6 minus 2 is 4, minus 3, so 20 minus 3 is 17. Okay, example 3, the graph of function f is shown to the right, and we're going to evaluate some compositions. Okay, compositions, we treat them like compositions, but they're composition of functions, so we're going to be careful. And these are kind of going from easy to hard. Okay, so this is the limit as x approaches 4 of f of x. So I'm going to apply the limit to the inner function first. Okay, as x approaches 4 on this graph, this looks like it's approaching From the left, the y is approaching 1. From the right, the y is approaching 1. So it's going to equal to 1. But I'm not going to plug in 1 here. This is not f of 1. This is still a limit. So it's saying, instead of saying f of 1, where I'm saying x is 1, I want to say this is the limit as x approaches 1 of f of x. Okay, so instead of saying f of 1, I still need to write this in function notation. Now I'm going to evaluate the limits x approaches 1 of f of x. So as x approaches 1, that's down here. The y value is negative 1 in both directions. So the answer to this is going to be negative 1. Okay, let's try the next one. And I did warn you, each one's going to get a teeny bit harder. Okay, B, the limit as x approaches negative 1 of f of x. Okay, it's a composition. So I'm going to first apply this limit to the inner function. So I want the limit as x approaches negative 5 of f of x. As x approaches negative 5, that is up here. And I can see in both directions, it looks like the y value is approaching 2. If this were a composition, I would now write f of 2. But it's not a composition, it's a limit. So instead of saying x is 2, I want to say the limit as x approaches 2 of f of x. And then on the graph, instead of going to f of 2, I'm going to look what the limit is as x approaches 2. Okay, as x approaches 2, what do we got? Let's see. Oh, at 2, there's a jump. So the limit on the left is negative 1. On the right, it's lower. So this limit does not exist. Okay, and that's a situation where it matters that this is a limit, because if it had said f of 2, the value would be negative 1. But since it said the limit is x approaches 2, it does not exist. Okay, C has a star because it is very tricky. Okay, last one says the limit is x approaches 2 of f of x. Composition, I'm going to apply the limit to the inner function. Okay, so as x approaches 2, I can see the limit does not exist. That does not mean that the composition does not exist. It just means that individual limit does not exist. And I need to evaluate it from the left and the right, because it does work in each direction. Okay, so let's consider this from the left and the right. So the limit as x approaches 2 from the negative of f of x. Okay, if I approach from the negative side, the y value is approaching negative 1. And because this is a composition, this is the limit as x approaches negative 1 of f of x. And then let me look and see if this exists. And at negative 1, the y value is approaching negative 1. Okay, now let me check from the positive side to see if it matches, because it's possible that this composition does work. Of f of x, and I'm going to apply it to the inner function. So if I come from the positive side, the y value is going to negative 2. Okay, the limit as x approaches negative 2 of f of x, right here, is also negative 1. So the limit as x approaches 2 from the negative side is negative 1, and as x approaches 2 from the positive side is also negative 1, which means the limit as x approaches 2 of f of x is negative 1.